So I am Bhartendu, and in this video we will know something about data science. So before knowing about data science, let me introduce myself. Yeah, so currently I am research fellow at TCS Research, and I joined TCS Research in 2023 right after completing my masters from ISC. So I did my masters in artificial intelligence. This is my gate history. So I tend to give gate generally, and I have around 100 rank mostly these years. So yeah, I was a gold medalist in my BTech, and also in my masters in ISC I got the perfect score in my masters project. And till date I have published like 9 research papers and filed 2 patents. So I know something about data science. So let's share this knowledge. Yeah. So particularly today, what I'll be focusing on is to LLMs. So just like basics. And just have a mental model about LLMs, so that whenever we are using or maybe in our work we have to integrate LLMs as some component. So in any of these cases we should have a clear mental model of what LLMs are. So we should be today removing the curtain from the magic of LLMs, and we'll try to see what actually is happening. So that's my motive, and this will also highlight different developments in data science, particularly like deep learning and many other things. So yeah, we'll look to it. So yeah, the basic premise would be to firstly convince you that why you should know LLMs better, and the second thing would be to make an analogy to calculators. So we will see how different or how same are LLMs and calculators. So we'll see in a while, and yeah, maybe this would be a good time to pause and maybe go ahead in the lecture yourself, as in what are calculators, what are LLMs, and if you can make some parallels yourself, or maybe why you should know LLMs better. But yeah, let's proceed. So yeah, so one line quote that I tend to give to motivate people to know more about LLMs is, these days it is absolutely necessary to use LLMs at least at a personal scale. As in, whatever you are doing, you may be a writer, you may be in coding, you may be doing finance, you may be doing management, HR, anything. Inadvertently you have to use LLMs in your task. So we use ChatGPT and the siblings right here and there. So yeah, that's the thing is, these days LLMs have become our teammate, our co-pilots as per se. So we should be very well knowing the capabilities and limitations of our teammates, or who our teammates are truly, so that we can utilize them better and work with them better. So same analogy that we have in our real life with our actual teammates, as in we should know them better, same with LLMs. Yeah. So the first mental model that I want to drive in is the output quality. So here by output I mean the response from any LLM. So simply like when we go to maybe chat gpt, that's the very famous LLM these days. So yeah, when we go to ChatGPT, we ask something and it gives some output. Like anything we can ask, it gives some output. So that's what I mean when I tend to say output quality. So output is the response of an LLM. So that is a function. A function means that is dependent on your prompt quality. So what do I mean by prompt quality is whatever I input here. So in this input box I tend to ask something, I tend to pose some question. So that is my input prompt. So you should be very careful about this word input prompt, and output is response, because starting with these very intuitive words, we will be building technical words and concepts out of it. So input prompts and response are two keywords that we have covered till now. So yeah, input and then output. So output is what we want to be very better. So we want output to exactly answer our query or exactly solve our discussion or whatever we are seeking. So that is dependent on our input, as in same thing we can ask in n different ways, and each of them will have varying quality of response. And the second thing on which the output depends is the model quality. So like these days there are many different models. Yeah, so the more powerful the model, generally the better is our quality. So the thing is, but the more powerful models either give you lesser number of requests or lesser number of inputs to be made in a day, or they charge you more. So there are two popular ways to use any LLM. So first way is like these chatbot kind of UI interface where I do input something, I get output something. The second is API. By API, what it means is we have a function in our Python or any language, and there we call a server. A server can be an OpenAI server, Google server, where in this call, this input is sitting somewhere in this call, which goes to that server, and that server again has a LLM, and that processes this input and then gives a call back to the function, and then the functionality goes on. So this is APIs are generally needed when we are building stuffs. So if we are building things with LLM, so you can think of n number of ways to automate things with LLMs. So wherever LLMs come into picture when you are building an app, a software, or automating something, so then we need APIs. And when we are just like interacting, question answering, some discussions, then generally the chat interfaces are enough. So in both the cases we have to select models. So like in this, like there are many different models provided by OpenAI, and some are more expensive than others. Like this 4.5 is more expensive by O1. By more expensive, I mean if you do a API call, so cost will be more, or if you just select that model and do the chat, you will be having lesser number of interactions to do. Like for example, maybe this model which is superior 4.5, you might can only make 5 calls per day, and maybe O1 which is still a good great model but not at the level of 4.5, so you might make 10 requests. So 5 requests for 4.5, 10 requests for O1, so like that. So and the 4.0 is now a base model, or pretty much not the most powerful model, so you can might make like 50 calls or so. So yes, our output is dependent on how powerful is the model and how you are inputting. As in, one golden rule or rule of thumb is whatever comes to your mind, just write it. Give more context, it will give you better output. So that is like one established thing. Ki if you write more, whatever you have in your mind, it will output better. Yeah, so that's one thing to know. And yeah, second thing is like everything has characteristics, or everything has their own metrics, properties. So LLMs have also many different properties. So these are 7 essential properties that we should be knowing about LLMs whenever we are using them. So yeah, first property is input context length. So input context length is like we input something to LLM, like my name is, and I'll write something 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 more. So input context length is the maximum length of the input that I can put to a model. Yeah. and output context length is the maximum output length, maybe if you can count in words, then words, that the model can output. So now the catch is everything in LLMs go via tokens, or in the concept of tokens, not words. So we'll just right away dive into tokens, but just bear with me, as in with these seven properties. So first is input context length. So the more input you give to the model, generally it is more expensive. And if the model outputs more length, it is again more expensive. Then third property is speed of a model. So few models tend to output slowly, few models tends to output fast. So anything about as LLMs is measured in tokens. So for this slide, just have a mental picture is token as words. So each word is maybe one token. That's not true. We will just see in a while. But if you have that mental model that one word is one token, then like speed makes sense. How many words per second the model can output? Why this is important? As in both chat UI and API, it is important. In API, if you are like having synchronized with something, or in real time responses you are giving, if slower model is there, then it might mess up things. Same with chat UI, as in you do not like to be weighted. Like if your output is like one word per second, so in every second it is outputting one word, you probably would not use that model. So there are then these two model configurations or model tweaks. One is temperature and top k, we'll just see in a while. And sixth one is number of parameters. So number of parameters is number of weights or values saved in a model. So any neural network, LLM is a neural network, is just weights or parameters saved. And there's this specification as in how these parameters will mix up with the input to give the output. So any neural network is just two things: firstly, all the different parameters that it has, and secondly, how these parameters will gel in with the input to give the output. For example, if I have a very simple network with only one parameter, so that parameter can have a value like maybe 2.5. So one parameter value 2.5. And so first thing I have defined how many parameters, what are the values. So one parameter, the value is 2.5. So now second thing I have to specify. Second thing is how this parameter will gel in with the input to give the output. So maybe I define you give me a input and I will multiply this and give the output. So whatever be input, maybe input is 1, 2.5 will be multiplied, output is 2.5. Input is 2, 2.5 will be multiplied, output will be 5. So like that, any neural network is just specification of two things: how many parameters and their values, and how these parameters will gel in. So gel in we define in technical terms as multiplications and additions. So generally any of these neural networks, generally what they does is they do multiplications and additions at scale. So there are many parameters, all are being multiplied with things and being added with things, so millions of them and millions of computations. So parameter essentially defines how large is my model. So in my example, when I had only one parameter, this is a very small model with one parameter. And these days these LLMs have like close to billion parameters. So all of those parameters, we have to give value for them, and how they will gel in with the input to give the output. So that's something to take care. As you might have heard about GPUs, size of GPU, okay, it is 36 GB GPU, 48 GB GPU. So all of these parameters that a LLM has or a neural network has to sit in the GPU. So every parameter will take some space. So it is generally a real number, or real number you can just sense like something with a value 2.5, 10, 1000, something, a decimal point number, and that needs some bits for storage or some memory to be stored. So when I have like millions or billions of them, so I need maybe GBs or TBs of them. So that's why it is costly to run LLMs or do anything with LLMs. That's why these OpenAI, Gemini, other players charge you money, because these models are having billions of parameters. So these are in maybe multi hundred GBs or TBs. So to give you an example, you might have heard about DeepSeek. So DeepSeek has about 650 million parameters, and it's around 1000 GB. So you need GPU close to 1000 GB to put all these parameters in that GPU and then do input and output. So parameters is very important as in cost perspective, and in general, larger the model, better is the quality. That is like to be read with a pinch of salt, but that is the case. Yeah. And the seventh thing is not technical but highly non-technical, as in what these LLMs are capable of and what they are not. So yeah, so enough about maybe tokens that we have heard here and there now. So now we'll concretely see what is a token. So yeah, so what we generally do when interacting with an LLM, we give a input which is collection of words or sequence of words we give, and maybe we just give it as an input, and model gives us some output. So yeah, model will give, yeah, so this is the model's output. Again, input is sequence of words, output is sequence of words, but we have to stop there, as this is just human perspective or for humans to see. As in we have already touched upon that any model is just many parameters. These parameters are some decimal values, something 2.5, 10, 100, and how they multiply and divide with the input. So you have to then think, if these are decimal points, parameters are decimal points, and these can only be multiplied and divided or added, subtraction with the input, then inputs need to be also numbers, decimal numbers, integers, or so. Input can't be a word. So like input can't be like my word can't be an input, because model is sitting there having parameters are decimal values waiting to be added and multiplied with the input. But if your input goes as my English, model does not understand anything. It can't multiply and or divide or do any of these numerical things. So what it happens is, we are just seeing this thing as the English sequence of words input, sequence of words output. Model necessary, any neural network has to see sequence of numbers, can be integers, can be decimals. Decimals are what called real numbers. So what will be happening inside or is, I, after pressing enter, my name is Bhartendra, enter, this gets converted into a sequence of integers, and then model gets that input to work with, and those integers are then played with, as in multiplication, subtractions, and all different things. And then model outputs again a sequence of integers, which are again mapped to English to us for to see. So that's what is the first level in your mental modeling. As in we are seeing words, model just sees numbers. So under the hood, the first step is English to in numbers, and the last step would be numbers to English. When model outputs a sequence of numbers, it is converted to English. So there is one kind of a mapping. Mapping means something from English has a corresponding thing in a number. Like with yeah, this mapping is called tokenization. So and these numbers are called tokens. Yeah, yeah. So like for example, you can see, yeah. So this thing, my name is Bhartendu. What if is happening is, for your models like ChatGPT, this is broken down first into these seven pieces or seven tokens, and each of these seven pieces have a corresponding number. So here my, and then space with name, space with is, space with bh, and then art, end, u. So these are seven breakings or seven chunks that happen from my English. So I entered English thing, my name is Bhartendu. What happens is there are slicing. So this slicing happens, and then each slice has a predefined number. So this would have been somewhere in the memory saved that my is the number 5159, is, or space with a is a number 374. So okay, this thing, to just explain it better, what I can do is, yeah, what I can do is, we can have a very crude or very simple tokenization algorithm, as in any alphabet will be assigned to the number from 1 to 26 based on its position. So A will be 1, B will be 2, Z will be 26. So that is one algorithm, and space will be maybe 27. So now what will happen is, I have one mechanism to convert English to numbers. Very easy mechanism. So what is happening is M, and if we just ignore the cases, then M is then 13, Y is 25, and then the space 27. So like that, if we do, we get this sequence of numbers from this English thing. So this is to be kept in mind, as in we have thought of about very simple algorithm to transfer from English to numbers, and we can now translate any English sentence which is made up of these 26 alphabets and the space. So these 27, if I say constructs, whatever sentences, whatever paragraphs are made, I can just have a sequence of numbers. So this is the spirit of tokenization, that whatever is in English, convert it into numbers. But here's the catch, as in ki, this trivial algorithm of maybe 27 tokens is giving me this big number sequence. So the bigger the number sequence, it will be more computations to do. As I said, ki any of these neural network are just parameters sitting in GPUs. So some decimal numbers and specified with ki how it will be gelling in with the input, as in ki how it will be multiplied or added. So the more is the sequence of numbers in the input, more multiplications, divisions, additions have to be done. So ideally, to save our GPU cost, we need this sequence to be very small. So imagine if this is just one length, like some one number like 29. So then we will be just having a very small input, and the computations will be less. So yeah, that's the aim of tokenization, as in not just to convert English to numbers or sequence of numbers, but the shortest possible sequence of numbers. So now you get it. There are many tokenization algorithms, all are focusing on just one thing, as in how to convert English sequence of words to sequence of numbers in the smallest possible way. So how they do it is like one example. Yeah. So if I think that how can I make it shorter, so what I can do is now, in I was just taking 26 alphabets and the space. So 27 were my unique integer values that I was using in my sequence. What I can do is I can use the next integer value like 28 and assign it to a group of alphabets. So the alphabets that are occurring very frequently in different inputs, so that are grouped together. So for one again crude example, what I can do is till 27 I have defined 1 to 26 are A to Z, and 27 is space. 28 I can define as Bhartendu. So this word I define as the one token, so 28 token. So now what will happen, as in the long I think 20 length sequence, that was because of our initial algorithm, which was if you just forget this third point, which was just these 2 points 1 to 26 A to Z and space 27. Now we added a new token. That token is Bhartendu, and a number corresponding to that token is the next number 28. So now our token size or number of tokens is 28, and now from this 20 length sequence I can get to 12 length. So what was happening, if I had not have this Bhartendu token, so I would have to assign numbers for each of these alphabets, and it will be long. So it will be like 20 numbers, so sequence of 20 numbers. Now what I did is, for entire word Bhartendu I defined 28, so everything compressed into one. So now this is just 12 length. So that's how tokenization work, and it starts with very basic these things like alphabets and so, and it goes on adding new tokens. Like Bhartendu is a new token, it goes on adding new tokens and assigning the next integer to it. So yeah, just to give you an idea as in what is used today, so these OpenAI and Gemini, Google's and other players are having tokens around 1 million tokens, so 1 million different tokens. And yeah, so just this thing, you can see ki this is actually from maybe OpenAI, how OpenAI does it. So these are actually very frequently occurring words like my, space with a name, space with a is, very frequently occurring. Obviously Bhartendu is not a frequently occurring, but you can see ART. Art is a very frequently occurring word, same with END. So these are tokens in that tokenization algorithm. And so because these became tokens, so U maybe is left, and dot and space BH is left. But yeah, the spirit is ki what they do is not alphabets, but they try to have a group of alphabets that are frequently occurring into tokens. So that's how now we'll just see one visualization of LLM. So yeah, my name is Bhartendu. If I do, and if I put generate, so see my name is BHARTENDU. So this in English we see, but we have seen ki this get translated into C number 7 6 yeah, so it's numbers. And now this is internally what a LLM is, and what happens is it predicts probabilities for the next token. So you can see there are like many different tokens. So see token ID and probabilities for the next token are there. For a comma there's like 40% probability. For maybe Kumar currently there is 0% probability. So just to end it, we will just see two parameters or two configurations of LLMs. So one is temperature, one is top K. Very easy thing. So top K is how many tokens will have non-zero probability in the prediction. So see, if I have k equal to 1, then only one token will be considered in assigning probability. If I do it two two tokens will have some probability, top 2 1, 6 top 6 1. So this is the important parameter, as in to explore more or to just use the prediction the model is doing. So see, if I increase it slightly to maybe 18 or to 20, so you can see Kumar is now getting some percentage. And temperature is second parameter. So in very crude sense, temperature means more is the temperature, more creative is the model, or model will explore more, and lesser is the temperature, model will just stick to whatever training it had done, and it will not be creative. So in that sense, if I have very less temperature, so comma gets 89 percentage, as in key in many of the situations in this scenario it has seen a comma. And if I do more, then see it is getting to be creative, and even now Kumar has more percentage. And so yeah, so that is yeah, that is maybe something, yeah, that is about yeah, LLMs. And just to uh, conclude this calculator thing, so see, what is a calculator? A calculator is a program that takes in few numbers. So if I have maybe in calculator with my computer, so yeah, so yeah, this is a calculator. So what it does, it inputs some numbers and some special characters. So 78 2 are numbers, and this star or cross is a special character. That's what happens as an input for an LLM. We had seen there are sequence of numbers, and special characters can be comma, space, those things. So same as calculator takes in input a sequence of numbers, so it can be -9 +3, like that. So sequence of numbers and some special characters, calculators also take, LLMs also take. And then if I just press equal to, so some arithmetic operations happens, as in some multiplication, division, addition happens. That same happens with an LLM, as in those parameters sitting in the GPU do some multiplication, addition with your input and give a output. So output in LLM is again a sequence of numbers. Output in a calculator is generally one number, but that is a special case of a sequence of numbers. So mentally, if we just forget what is happening inside or how complicated is the algorithm inside, if I just look at input, output and computation, the mental model for calculator is exactly same for LLMs, as in sequence of numbers and some special characters as input, some computation, addition, multiplication being done, and output is again sequence of numbers. So just the difference between calculator and the LLM is at a scale. LLMs have like billions additions and subtractions happening, and so calculators like generally do a few 10 or 5 calculations. Yeah, so yeah, that by that, yeah, it should be, yeah, ending. And yeah, have a nice day.